Hello everyone. Here are some different radar controls and their functions. First is, what is radar? A marine radar with automatic radar plotting aids capability can create track using radar contract. The system can calculate the track object's course, speed, and closest point of approach nearby, knowing if there is a danger or collision with the other ships or landmass. Track can be made utilizing radar contract and a marine radar equipped with automatic radar plotting assistance. The system can determine whether there is a risk of collision with another ship or a landmass by calculating the track object's path, speed, and closest point of approach. Next is function of a radar. A computerized adds-on to a radar called Arpa, Automatic Radar Plotting Aid, in order to calculate the collision avoidance data and make it easier for user to do so. Arpa uses feeds of its own ship's course and speed and the target course and speed. Arpa, or simply Automatic Radar Plotting Aid, is a computerized additional features to a radar. Arpa takes feed on its own ship's course and speed of target course and speed, and calculating the collision avoidance data simplifies that we need the user to calculate the data themselves. Next is the importance of radar. A mandatory aids to navigation, and radar is used to identify tracking with integrated ARPA and positioning of vessel, including one own vessel, among other things, in order to adhere to the call reg so as to safely navigate a ship from one point to another. And also, it can provide all the necessary information for the radar users and help in saving a lot of critical time from observing the target to find the data using radar plotting and calculations. Collisions, avoidance, and detection data is thus readily available to the radar users in no time just by clicking on the target. And then the last part is the radar controls. The first is power, standby, and transmit. The power, standby, and transmit switch usually has 3 positions. Pressing the power switch will activate the radar to standby. However, it doesn't come on immediately as the magnetron needs a few minutes to warm up before it can transmit. Then the next one is the brilliance. The brilliance control on an analog radar or old style controls the brightness of the rotating trace and will also affects the brightness of the displayed echo, so it needs to be adjusted so that the trace itself is just visible to give a good contrast between echo and background. Next is gain. The gain controls may appear to the function like the brilliance control in that it makes the picture brighter or darker. And then the fourth one is the heading marker. The heading marker and the range rings can also obscure small targets, so it's good idea to have the range rings turned off when they are not used and to delete the heading marker every few minutes to see if it is masking or small target. The fifth one is the range. The range control regulates the range at which the set operates by changing the size or scale of the area on the display. Changing range also affects the radar pulse length, PRF or pulse repetition, frequency, and video presentation. The next one is the tuning. The tuning controls can compare to the tuning control of an ordinary radio in that it turns the receiver to the frequency of the transmitter. Next is the anti-sea and rain clutter. The sea clutter control, it works by reducing the receiving gain for a few microseconds after each pulse is transmitted, then gradually restore it to its former level. The rain clutter control will reduce the interference on the screen due to the rain and increase the chance of seeing target within the rain shower. Next is the echo enhancement. To assist the operator to spot a small target, most modern radar have the ability to expand them, usually named echo stretch or expansion. It shows object to make it small target look bigger. Next is the heading marker and range ring. The heading marker and the range ring can obstruct small targets, so it's good idea to have the range ring turned off when they are in use, and to delete the heading marker every few minutes to see if it is the masking small target dead ahead. And then the second to the last is the pulse length control. The pulse length is normally selected automatically with the range scale on most sets. However, in the mid-range 6 mile to 48 mile on the 72 mile radar, it's possible to manually select the pulse length, which will have the significant effect on the radar performance. And the last one is the off-centering. By using off-centering controls, the center of the picture can be moved downward or upward, and on some newer sets, it can also be moved sideways. And that's all for today. Thank you for watching.